Hi Hemant, Abhiroop, Jyoti, Darshan, Ashish. Yeah, all of you, good afternoon. Good afternoon. Again, I think some flurry of doubts. Let me clarify them one by one. Okay. Yeah, let me revise the topic first, then I'll take your doubts. So we are discussing plate tectonics. We have finished the idea of divergent boundaries, and then we were discussing convergent boundaries. Okay. So divergent boundaries happen at descending convection current. Sorry. Yeah. Yes. Ascending and diverging. Diverging convection current limbs. They can be under the continents. They can be under the oceans. Under oceans, they become sea floor spreading process. And if they are part of continents, this leads to continental split, nascent ocean formation, proper ocean, and this becomes ultimately sea floor spreading. I believe no problem in this. African Rift Valley, the Doman upliftment. One more concept here called as triple junctions. These ultimately become locations of ocean crust formation. Okay, I think these concepts are fine, all of you. Okay, anybody has any doubts here, ask me. Ascending limbs that diverge out, the oceans can get stretched, pulled, broken, more formation, axial rift valley formation, the formation of ocean crust itself, basalt, lava, and the entire Harry Hess story thereafter. Continents first will bend, domal upliftment, the continents start stretching, rifting. Okay, ultimately they'll break apart. They break apart, forming a small, narrow, nascent ocean, young ocean, and it goes on. It becomes a proper ocean. And we added here that this mechanism is the mechanism how the Pangea broke up, how Gondwana land has broken up, why South America separates from Africa, and you have the entire range of discussions there. All fine, all of you? Any doubts in this? Hi Karan, Nidhi, Aditi, Mehak, आप online कब चले गए? I was missing some of you since the pre-Diwali days. Okay, so some of you have moved. Okay, why there is no continental plate only? Abhiroop है, छोटे वाले हैं. And if you wait long enough, you might see one more. ऐसा कोई rule नहीं है, continental plates can't be. There are the smaller ones. The bigger ones that we have, okay, are including oceans, because oceans are the bulk of our surface. Oceans are 3/4 of the bade wale plates hain, they have some ocean part. That's it. Anybody else here? All good here? Can I move on from here? Okay. So let's move on towards the convergent boundaries. Acha, I had used one more term here. Divergent boundaries are also called as, yes, constructive boundaries. Yes, I hope you have done that. Did you all make your, or try making your summaries of diagrams? Okay, 2-3-4 page mein. Okay, yeah, please do that. That helps you, revise better. Okay, good, nice. You have done it very excellent. Nice. Okay, now convergent boundaries at locations of descending limbs. There are 3 types of convergent boundaries: ocean-ocean collision, ocean-continent, and CC type. And one thing we explained yesterday was that they might look like 3 different boundaries. They actually are, okay, different stages in the sequence of convergent boundary development. Okay, I can start from O type, one ocean floor subducts, it converts into OC type, then that ocean floor subducts, it then becomes CC type. It's something like there's a child, an adult, and an old man. ये 3 अलग life forms नहीं है. Okay, they essentially are 3 stages in the sequence of how a man grows and becomes older. Okay, so a child has different properties, an adult has different properties, different behaviors, and so on. But actually, वो एक timeline ही है. That's a very important idea to understand why the forces become strong towards CC, why the amount of sediments increase towards CC. So you have a continent, I have an ocean floor, I have a subducting ocean floor, and I have another continent. Okay, the location of descending limbs is here. In time, this subducts. So the continent moves here probably, pass aa gaya. This is here. The entire ocean floor has subducted, and this boundary continues to be here. In this collision, now this will start going in. Okay, continents will not subduct. Continents are lighter, continents are buoyant, continents will resist subduction. Oceans are denser, oceans are thinner, they can be pulled inside mantle a bit more easily. So this was an example of, okay, ocean collision. Okay, once ocean slab has gone, it converts into ocean continent, and if this process goes on, the 2 continents now come face to face. You still have, okay, the descending limbs operating, and in between all these, we see accumulations of sediments. We have accretionary prism here. The accretionary prism, more enormous, more diverse, more complex here. And this is even more enormous, okay, between the 2 continents. Okay, and at the CC collisions, you have the strongest compressive forces. You have the maximum accretionary prism, there is no subduction and therefore no volcanism, but these are zones of earthquakes and also a high mountain building. Is this sequence okay with all of you? The three type of convergent boundaries are essentially three stages in how the convergent process operates. Examples of CC, अरे जितने भी आपके continental word locations of mountains हैं, you have Himalayan location, Hindu Kush location. I mentioned Kunlun Shan is a. I'll draw those mountains eventually. China में है continental word location. We have some mountains of Iran in the north called as Elburz. We have Caucasus mountains. Okay, so बहुत सारे mountains हैं. All the mountain, fold mountain, not any mountain. All the fold mountains which are away from the coast. They're examples of CC. Even Urals, correct. Urals, but difference is Urals में अब activity नहीं है. Okay, the collision process has stopped and Ural is now a very old eroded mountain, residual mountain. But Ural, when it was forming, it was CC type of collisions also. Alps में the mix है. Northern part of Alps has CC type and parts of southern Alps also has some elements of OC type also. This process is clear. Respond to your doubts. Abhiru. I don't know what you're asking me. Hard rocks, there is no dome. Why are you saying that? Okay. Faults will be there. Domal mountain is essentially an swelling, that's all. Okay. It's a swelling on the surface. So it looks like a highland. So mountain mat bolo, we call it as Ethiopian highlands. Yes, Anogya, Aravalis also are examples of very, very ancient CC collisions. Yes. Okay. So folding and faulting, they can happen together also. Abhiroop, आप थोड़ा सा आगे चल जा रहे हो. Okay. So I have to ignore you now because your doubts tell me you know the concepts you're confirming from me. Okay. So I will hold you for some time. Aditi. Continents do not subduct, but can two continents plates overlap? These doubts tell me you know something already. Okay. Yes, you have read right. Okay. I'll hit it when I come to it. Why does CC collision does not have back arc? Okay. अब बताओ कैसे back arc बनेगा? I have continent. Yes, 2-3 of you have asked me this now. ये ocean है. This ocean subducting. So when this melts, you have volcanic arc. तो ये back arc बन रहा है. Back arc is ocean. जब ये ocean ही नहीं है, I have continent here. Okay, and you have subduction going on here. This rising creates volcano here. ये back arc कैसे बनेगा? जब ये island ही नहीं है. I don't know why this is such a big doubt. So many of you have asked me. Back arc is what? Back arc is a part of a ocean basin. Back arc में पानी होना चाहिए. Okay. So ocean is there, it is a back arc. And when I say arc, I mean what arc is this? This is an island arc. Will I call the mountains on the fold mountains as islands now? पानी आपका यहाँ पर है. तो इसको arc क्यों बोलोगे in the first place? One. Number two, how can you have a back arc here? जब ये खुद ही arc नहीं है and there's no water. I don't know why so many of you had a question on this. Why don't we not have a back arc in OC collision? This is why. Anybody doubts offline में यहाँ पर? Anybody doubts here? Okay, Hemant. आपको जैसे याद रहे. But please use, see, imagination करना कुछ भी कर लो. Okay, but write the language of the geomorphology. When it says domal mountain, you say domal mountain. Okay. When it says fold mountain, you say fold mountain. All done here? Okay. So, quickly I will summarize for you. OO collision. OO collision, ocean subducts. There is a trench. There is accretionary prism, volcanic island arcs called as archipelagos. These are andesite volcanic eruptions. There will be a back arc, marginal sea. Kuch chota point? Okay. These are the 6 points you must know, features associated with OO collisions. OC collisions, again ocean subducts. There is enormous and a very diverse accretionary prism. It forms fold mountains along the coast. There are volcanic eruptions on the fold mountains. The eruptions will be andesite eruptions, plus there are also granitic intrusive landforms. Could you miss 4 points? Yeah? Oh, yes, yes. You also will have subduction, so you also will have a trench. Correct. आपको ऐसे ही याद रखना है. Okay, you take up a feature once you know the process. जब आंसर लिखना शुरू करो, this should be in your mind already. ये याद होना चाहिए. What are the 6 features, 5 features linked to ocean continent? And I have said this is far more enormous, more diverse prism. So this becomes proper fold mountains. You can add one term here. These type of fold mountains जो बनते हैं along the coast, they are also called as cordillera. It's a Spanish word which means mountains. Okay, but we use this mainly for the mountains along the coast. ठीक है? So अपने notes में go back to yesterday's class notes. वहाँ add करो. Okay, the fold mountains along the edge of continents because of OC collisions. We also call these as cordillera type of mountains. And these are cordillera type of mountains. Rockies are cordillera mountains. When I use the word cordillera, 3 things. These are fold mountains. These will be along the coast, and they also are a series of parallel ranges. So, ये continent है, one range, second range, third range, ऐसे ranges होंगे parallel. Okay, so cordillera means fold mountains. Cordillera means they're always along the coast, and also they are a series of parallel ranges. All good, all of you? All done? No, Anugya, there is some difference. Okay, it's like the baby becomes the adult. Of course, कुछ similarity रहेगा, but then adult is not same as the baby. So Himalayan mountains will have some similarities with Andes mountains because there was a time when Himalayas were like Andes mountains. Okay, but Himalayas are not same as Andes mountains. So there will be some variations. आप खुद बता सकते हो क्या क्या variation होने वाला है. One big variation will be the Himalayan type of mountains will not have active volcanism. Okay, they will not have active eruptions. One big difference will be Himalayan type of mountains are far more higher. Okay, they'll have more complex formations. And yesterday I mentioned all the complex features, okay, which is more likely in CC type and less likely in the OC type. Okay, all of you done? The features of OC collision, and then we have the features of CC collision. CC collision, okay, so this is, okay, there is no trench. These force a very strong compression. So, a very high fold mountains, no trench, and there is no subduction. There is no trench formation and there is no subduction. They'll force very strong compressive forces. The compression is very, very strong. Very high fold mountains, and such fold mountains will have complex features. They will have complex folds. No trench, no subduction. So there is no active volcanism. There is no active volcanism. Okay. Why conversation? क्या प्रीति? मैं समझ नहीं पाया. फातिमा आप याद करो, अब रट्टा मारो आप, ठीक है. Why no volcanoes? लिख लो, you will understand eventually. And very high fold mountains, very complex features, complex folds, and I gave you a list. We'll have hogback features, we will have overturned folds. I've also mentioned these are asymmetrical folds. We will have recumbent folds, and one term I mentioned yesterday was the nappy structures. Nappy structures where the folds are now broken. Okay, the folds are broken. So for imagination, I said, imagine the fold mountain hai, and the compression is going on here. It's compressing, it's compressing, it's compressing like this. It becomes steep. If one is far more stronger compression, will force the fold mountain to turn. It turns, overturn fold. It falls on the ground, and then you keep on pushing. This will break, and the limbs will now split like this. Okay, the upper limb has gone ahead, the lower limb has been pushed back. This type of split is called as nappy structures. Okay, so ये सब features आपको Himalayas में दिखता है. Okay, and many of you are asking me about faults. Beta, wherever we have very strong compressive forces, it is surprise क्यों हो? Along with folds, you can also have faults. Okay, इसमें इतना surprise क्या है? You are squeezing something. If it is, see, rocks are soft, but does not mean they are sponge. वो भी rock ही है, मारेंगे तो चोट लगेगा, right? It's a soft rock, but does not mean it is like a jelly. Okay, it can ductile and they can stretch into sheets. They're still rocks. They're soft rocks, but rocks. If you squeeze them hard enough, they also can break. You're right. So you can also have faults, not just in CC type. यहाँ भी faults हो सकता है, and we can also have faults, sorry, in OC type, and we can have faults also in the CC type. The nappy structure, we can also have lot of faults. Faults are what? Faults are cracks. Okay, the rock is broken, we'll have faults. That color, no problem. अभिरूप है ना, इतना इम्पेशंस नहीं, आपको बस वो वर्ड सुनना है, ठीक है, मुझसे। मैं छेड़ता रहता हूं, नहीं सुनाऊंगा आपको, तो और परेशान हो, तड़प जाओ, पानी पानी करो, ओके, फिर बता देंगे आपको हम, ठीक है। आई ऑल्सो हैव माई माइंड गेम, स्ट्रॉन्गेस्ट विल विन। और क्या बताओ ऑफलाइन गाइस, एनीबडी? आई थिंक योर डाउट्स ऑनलाइन गाइस आर आस्किंग, राइट? बिकॉज एनोनिमस हो तो कुछ भी बोल के निकल जाते हो, ठीक है। तो ऑफलाइन गाइस दे आर अ बिट मोर कॉन्शियस। अभिरूप, इसमें थोड़ा और तब आपको तड़ पाएंगे, अभी पूछते रहो, ये 2-3 बार टाइप करेगा अभी, ओके। यू नो व्हाट इज AA? वी कॉल दिस एज AA सिंड्रोम, अतृप्त आत्मा सिंड्रोम। भटकता रहेगा, ठीक है, थोड़ा अतृप्त रहो। Anybody else here? Chalo, so we have taken care of, okay, all the convergence interactions, and why are they formed, how are they formed, and now we'll stretch that to a bit more towards some earthquakes, some volcanism, and so on. Okay, so moving on, give a subheading, circum-Pacific belt of fire, also called as the ring of fire. Circum-Pacific belt of fire is also called as the ring of fire. Give us a heading, 3-4 lines on this. So ये है क्या? This is a zone of volcanoes and a very destructive, a very explosive type. They are zone of volcanoes. These are associated with very strong earthquakes. These are potential tsunami types. It's a zone of volcanoes, very destructive volcanoes, very explosive volcanoes. They're associated with very strong earthquakes, and these earthquakes can also cause tsunamis. And this zone, okay, lines the coasts of Pacific Ocean. When I say Pacific Ocean, I'm talking about, okay, Western Pacific, Northern Pacific, and also Eastern Pacific. The Western Pacific is, okay, starting from Kuril Islands through Japan, through Philippines, it goes into Indonesia and towards Southwest Pacific. ये पूरा zone is West Pacific. From Kuril Islands, it includes Japanese islands, it includes the Philippines Islands, into Indonesia and Southwest Pacific regions. This includes islands like Tonga Islands. A group of islands hai, called as the Tonga Islands. वहां पर है. Northern Pacific is the Aleutian Islands, north में. Aleutian Islands, Aleutian Trench, Bering Sea बताया था आपको कल मैंने. And Eastern Pacific is the western coasts of North America, Middle America, and South America. the western coast. East Pacific means the western coast of North America, South America, and Middle America. Middle America is Mexico. Okay, that strip of land. If you know, this Middle America is an area called as the Isthmus of Panama. Middle America is Isthmus of Panama. Okay, this zone is called as the Ring of Fire. Ring of Fire. Okay, this is a zone of active convergence, convergent boundary with ocean subduction. It's a zone of active convergent boundary with ocean subduction. Ocean is sinking. The West Pacific and the North Pacific, these are OO collision zones. The West Pacific and the North Pacific are OO collision zones, and the Eastern Pacific is OC collision zone. It is the OC collision zone. Okay? Yeah, Shweta, but Gulf of Panama is one of them. We also have Gulf of Darien. See the map once. Okay? This is all subduction zones. और अगर subduction zone है, we have said the volcanic eruptions, they will be andesitic. Any subduction जहां पर ocean floor subduct हो रहा है, it will be andesitic eruptions. Okay. The OO type will form island arcs, and OC type will form the Cordillera mountains plus the volcanic peaks. Okay, जो West Pacific है, OO collision, they will form island arcs, and if it is OC collision, they'll form Cordillera fold mountains and will form volcanic peaks. कल नाम बताया आपको मैंने, Denali Peak, Mount Whitney, Chimborazo, Cotopaxi, Ojos del Salados, Aconcagua. Okay, we have some mountains in Mexico. We have Popocatépetl and Popocatépetl, the two peaks of Mexico, which are explosive eruptions. I think Popocatépetl was erupting last year. Okay, so there are series of volcanoes, and all of them are andesite. I'll just add one word here. The andesite जो होता है, okay, remember it is viscous, it is very thick, okay, unlike basalt. This is unlike basalt. Basalt is fluid. Basalt will flow very easily. Basalt at the more will not cause explosive eruptions because वो आराम से बह जाएगा. It's a very fluid lava, whereas andesite is a thick lava. It's a viscous lava. Okay, it will not flow very easily. So it builds up pressure and then it explodes. Okay, so we have the viscous lava forming the explosive mountain. That's why we have all these tsunami problems there. Or Kamchatka Peninsula has been in news last couple of months. There are 2-3 events of very powerful eruptions and fears of tsunami as far as Hawaiian Islands also. Okay, the E zone is the Pacific Ring of Fire. So, because of Pacific Ring of Fire, which has active subduction boundaries, Pacific Ocean is shrinking. Ocean हर जगह subduct कर रहा है. Okay, so You have got subduction along the western side, along the eastern side. यहाँ पर continent है. Okay, sorry. ये continent है यहाँ पर. This is continent here. So यहाँ also it is shrinking. This also it is shrinking. So Pacific Ocean is becoming smaller. The Pacific Ring of Fire is a zone of active subduction boundaries, and therefore the Pacific Ocean is a shrinking ocean. वो छोटा हो रहा है. A couple of years from now, it goes on. The Chinese mainland, Japanese, and North America can fuse together and become again one large continent. That's how continents fusion happens eventually. It keeps on happening. Okay, this OO will convert into OC. So RD is OC, and they come together. Oceans are gone. It becomes CC, and this becomes one large continent eventually. Take all of you here. So what are the features? This was a question asked in your GS question. What are the characteristics of the Pacific Ring of Fire? So all these points you will mention. As a part of your diagram, let me see. We have the diagram here. We should have it. This is your Pacific Ring of Fire. Okay, this is the Western Pacific. This is a zone of ocean collision. The Japanese Kuril Islands, Japanese Island, Philippines Island, Indonesia. This also is O collision. यहाँ पर है. This part has Tonga Islands, New Zealand. North में also it is O collision, Aleutian Islands. This is Western Pacific, Northern Pacific, or Eastern Pacific है. This is OC collision, where the western coast of North America, this is the part of Central America, and this is South America. ये पूरे arc में you will have volcanic eruptions, you will have earthquakes, tsunamis, and because subduction going on, the two continents will come together and they ultimately will fuse. Okay? So I want this to be drawn in your notes. So let's try that. Good, bad, ugly. Aap, okay. You'll keep on trying. I'll find one of the days where I can help you draw New Zealand somewhere here. Okay. You needn't draw all the features. That's your Aleutian Islands, Kuril Islands, Japanese Islands. We have Philippines, and we have Borneo. Okay, so try karo, all of you, and your ring of fire is this. The Pacific Ring of Fire, like this. When I am drawing maps, no, you should notice हम क्या sequence maintain करते हैं. How do I draw it? I don't draw random. I have drawn the equator. You have a sense of north-south. I start from Siberia, Kamchatka, Korea, China, Vietnam. Okay. Then you have this Thailand, Malaysia, the islands of Indonesia, south of equator. Okay. This is a sequence I follow. Okay. If you draw randomly, okay, फिर आपका वो shape बनेगा नहीं. Okay. वैसे यहाँ पर Alaska, Aleutian Islands, you have a curve like this, a small tail of Californian Peninsula, Baja Peninsula, and then you have the west coast of South America. So notice this couple of times, so you will get a hang. What sequence am I following? Avicens proportion, Siberia, Kamchatka, Korea, China, Gulf of Tonkin, this is Vietnam, this is Thailand part, okay, Sumatra, Java, New Guinea Island, Australia, New Zealand, Alaska, 3 bends, bulge like this, and equator ko cross karte hue you have South America, right? Kuril Islands, Japanese Islands, Philippines Islands, and Borneo. Okay, equator cuts Sumatra, Borneo, not Java. This is the island of Java. This is the island of Sumatra. This is called as Borneo. This is the island of New Guinea. Philippines Island, Japanese Island, Kuril Islands. And these north mein, these are Aleutian Islands. Okay, I follow a sequence. Maintain that, your proportion will be fine. Exam hall mein, these sketches should not take you more than 30, 40, 50 seconds. You cannot afford to draw, okay, for 3 minutes. पूरा आंसर लिखना है आपको 10 मिनट में. Okay, so you should be very quick, fast, one smooth line, you are done. ठीक है? Yes, keep trying, Hemant. Keep trying. And then I used another color. So this is your ring of fire. All done, all of you? जापान के नीचे क्या आइलैंड्स हैं? ये फिलीपींस आइलैंड्स हैं. फिलीपींस. Okay, all of you done? Okay. So I am done with the convergent boundaries. Yeah, that helps, Hemant, that helps. Okay. Now let's move on towards the third type of boundary, which is transform boundary. The transform boundary. तो transform में क्या होता है? The plates slip past one another. So we have drawn this diagram couple of times. Two plates, and the plates are slipping. There's no convergence, there's no divergence. Okay, they are slipping past one another, kind of rubbing against each other. So when you have this, there is no convergence, there is no subduction. There is no crust destruction. There is no crust formation. We call these boundaries also as, therefore also called as conservative boundaries. Divergent boundaries are constructive boundaries. Convergent boundaries are destructive boundaries. Why? Because the ocean gets destroyed or the continents collide and they get crushed. तो वहां पे कुछ destruction चल रहा है. Convergent boundaries are called as destructive boundaries. नहीं लिखा तो लिख लो आप लोग. And they are called as conservative boundaries. There is no convergence, there is no subduction, there is no crustal destruction, and there is no crustal formation. Okay. Or because subduction है नहीं, therefore again there are no volcanoes. There are no volcanoes, but there can be very strong earthquakes. ये rubbing चल रहा है ना? They can have very strong earthquakes. These are seismic zones. They are seismic zones. बहुत examples हैं, but the most common one we talk about, आप इतना याद रखो. We have a small plate called as Juan de Fuca plate, which is a slipping past North American plate. A very small plate, a micro plate hai, sorry, minor plate hai, called as Juan de Fuca plate. Juan de Fuca plate that slip. Yes, you write with J, but pronounce as Y. Juan de Fuca plate. You're right. That's how Spanish pronounce it. ठीक है? हम देसी लोग हैं, हम जुआन ही बोलेंगे. Okay. So Juan de Fuca plate, slipping past North America. So in North America, somewhere here, okay, there is a small plate here. And relative to North America, this is moving like this, and North America relative is moving like this. Okay? And because of this, there is a massive fault. Crack, a boundary crack hai. The crack goes across California, Los Angeles, okay, San Francisco. It's called as San Andreas fault. ये active fault है. Okay. So Juan de Fuca plate on the transform boundary is associated with, okay, a fault. Yes, ये transform fault होगा, correct. Called as San Andreas fault. This is in California across San Francisco. सिटी के बीचों बीच ये एक फॉल्ट बना हुआ है. And this is a zone of lot of earthquakes, lot of devastations past में रहा है. बड़ा famous Hollywood movie भी है called as San Andreas. Okay, so San Andreas fault is one of those potential earthquake disaster regions of the world. Yes, yes, correct. This rubbing, slipping can cause faults also. यहाँ पर fault boundary ही है. Yes, we have one in Myanmar. अभी हुआ आपका earthquake called Sagaing fault. Okay, लिख लो, write down this point. Another example is the Sagaing fault. इस पे मेरा वीडियो भी है on the YouTube. You can have a look. In Myanmar, there is Sagaing fault. The Indo-Burma plate is again, okay, slipping past the Eurasian plate, Sagaing, SAGAING, Sagaing fault. वैसे अफगानिस्तान में इसका भी मैंने वीडियो बनाया हुआ है. There's one called as a Chaman fault. CHAMAN, sorry. Chaman fault. So ये वीडियोस आप देख लेना प्लीज. It's on the YouTube. Okay, Myanmar earthquake type करो, my name Edukemy, you'll have a video and see it. उसमें अच्छे diagrams भी हैं. I have drawn this. Yes, you also have one called as East Anatolia fault. ये टर्की में है. East Anatolia fault. So all of these are examples of transform boundaries. SAGAING, yes, Sagaing fault. Sagaing fault, Chaman fault, Chaman Badakhshan fault goes northwards. Yes, along Afghanistan, Pakistan, correct. And Turkey is called as the East Anatolia fault. यहाँ पर भी earthquake हुआ है. All of these are in news because they are earthquake locations in the recent past. Okay, nothing more to add here. Okay, so the three type of boundaries I have now discussed. What is divergent boundary, what is convergent boundary, and what is transform boundary. Any questions on this, anybody? बताओ इसमें क्या पूछना है? Boundary means the two plates have now completely split and they are now moving. Yes. Yeah. Yeah. Anywhere. So it can be active in this case, but of the other two, one of them will be failed. You'll have three junctions, hai na? Junction can be ridge, ridge, ridge. Junction can be a ridge system, convergent and transform. So both combinations possible hai. Okay. And of this, any two active, one will be dead. It's possible the transform is active and this one is dead. It's no longer there. So these triple junctions, the beginning of that boundary. Okay, this is where it starts. If it continues like this, okay, say imagine this was a large continent or large some plate. ये अभी triple junction है. When it's developing, all the three won't be active at the same time. Any two are active. Active hook is possible. This was active and this is active. Okay, this is not active. So now I have a plate, I have another plate. In this plate, this is a ridge system and this is a transform fault. And इसके बात नहीं कर रहे हैं. Okay, so there are many combinations of triple junctions possible. And not all triple junctions become boundaries. Examples I am giving you, they have become boundaries now. Okay, if the boundary is inactive, we have it here. Jैसे in case of Himalayas, Sagaing fault and we have one fault on this side. Himalayas is CC collision. And this one is, okay, an active fault here. Okay, and this is now a dead arm. So now this is part of one plate. And this is where you have Myanmar. Okay, these combinations are possible. Okay, for now remember that the transform boundaries, if active, are zones of powerful earthquakes. Okay, so I have taken care of all the three type of boundaries. Let's move on now. The next discussion is, what is the driving mechanism? Because see, this is the most important part of the theory. It was because of a wrong driving mechanism that Wegener was discarded, right? Okay, so I need to understand tectonics का driving mechanism क्या है? Okay, so it is not the tidal force of the sun and moon. It is not because of Earth's rotation. It is related to the dynamism of the mantle. Okay. It is related to the dynamism of the mantle. Okay. Now look at this. Look at, if I ask you, tell me, say you are successful, you become IAS officer, I ask you, कि बताओ आप successful कैसे हुए? What is the reason? One answer can be, I am successful because I cleared the examination. मैंने कहा ठीक है, और deep बताओ. I cleared the examination because I worked hard. A bit more, I worked hard because I had good mentorship, I had good guidance, and I was motivated. Can all the three be reasons? All the three are reasons at different depths. A superficial reason is I cleared the examination. A bit more deeper is I worked hard. You go on like that. So I say, if I ask you, what is the reason why the plates are moving? I'm saying it is dynamism of the mantle. Okay. The reason is linked to internal heat. The reason is linked to mantle convection cells. The reason is linked to a sea floor spreading process. हम ये भी कह सकते हैं. Sea floor spreading essentially is one of the mechanisms how the continents are breaking. If I ask you, tell us, why do the plates move? I can use all the three reasons. A superficial one is sea floor spreading. When the oceans are spreading, they are pushing the continents apart. ठीक है? तो और बताओ. The reason is convection cells. I can talk about ascending limbs, diverging limbs, and so on. अच्छा, ये क्यों बन रहा है? Because of internal heat. This I can say because of radioactivity, because of, remember, residual heat. The residual gravity heat, बताया था आपको मैंने. Okay. So the reasons for the tectonics and the plate movement are these. Okay. So plate motions are associated with the following forces. These three are the fundamental reasons what drives the plate. What drives the plate, it is not the attraction of sun and moon. What drives the plate is not Earth's rotation. Okay. What drives the plates are internal mantle conditions, the convection cells. So you can always add the theories related to Arthur Holmes, the concepts of Harry Hess. They tell us how the movement happens. And I'm saying that ये जो movement हो रहा है, इसके वजह से the plates are associated with the following types of forces. क्या क्या forces हैं action में? So ये continent है. This is the ocean subduction happening. This is the ocean subduction happening. Okay, and as the mantle cells are pulling them apart, the plates are moving and continents also get pushed out. अब इस process में one important force is this rising mantle and diverging mantle limb that is pulling the plates, right? Okay, so we call this as mantle traction force. This is the pull of the mantle which is pulling the floor apart. ये एक force है, the mantle traction force. We also call this as the mantle drag force. It is dragging Okay, the plates apart. Okay, Hemant, thank you. Being generous there. Mantle traction and mantle drag force. ये एक force है. Second force is, we also have some force because the slab is going down. Imagine this. Say this is the slab, okay? And there's some force which is pushing the slab like this. And because of push, the subduction starts. It's going inside. It's going inside. एक ऐसा time आएगा, because the slab is so heavy, even if I remove the force, the slab will fall. Why it falls? Because slab का अपना weight है. Slab has, okay, the capacity to pull because it is heavy. So we have one force acting here. It's called as the slab pull force. Is because of the weight of the subducting slab. तो एक तो mantle traction है, the mantle pulling it apart, and the second force is called as the slab pull force. Slab pull force, which is because of the weight of the subducting slab. It's because of the weight of the subducting slab. ये दो बहुत important forces हैं. Of course, ultimately linked to, I said, the convection cells. ये सब कुछ नहीं होता अगर ये convection cell नहीं होता. So this cell creates these two forces, the slab traction and the slab pull, the mantle traction and slab pull. इसके अलावा, yes. So intersection boundaries वो side by side है, like this one moves like this and this one moves like this. इसके ऊपर जो प्लेट है वैसे जाएगा, इसके ऊपर जो प्लेट है वैसे जाएगा. ठीक है? There is an asymmetry in their operations. Is it okay, all of you here? इसके अलावा, watch here. Say this is slab. There's some puncture here. Puncture here, lava comes out. And as lava comes out, lava अंदर जाकर it can open up the gap, become solid. A new lava comes in, again opens the gap. Again a new lava enters, again opens the gap. It's like कोई crack है, उस crack में आप कोई rod डालकर आप इसको से खोल रहे हो. You know, imagine here, you're prying it open. So this lava coming out at the ocean ridge, this lava, some amount of lava becomes solid. When the new lava enters, it is forcing the old lava out. Again becomes solid. Again a new lava comes out. Again forces the old lava out. This is called as the ridge push force. So there are three forces acting that make plate motions possible. The mantle traction drag because of the mantle convection cells, the slab pull because of weight of the ocean slab. Ocean slabs are heavy, dense, and the third is the ridge push force. The ridge push force. The mantle drag, the slab pull, and the ridge push. Of these, ये दोनों ज़्यादा powerful हैं, but you cannot ignore this either. The ridge push force is also a substantial force, but not as powerful as the mantle drag and the slab pull. All good, all of you? Okay. And you must compare this with what absurd ideas Taylor and Wegener had given. An imbalance of some crazy idea called center of buoyancy, center of flotation, center of gravity. All those were gibberish. The right reason is the mental dynamism makes this possible on the planet. Okay? Now see, the mental dynamism, what does it do? It creates crust, there are volcanic eruptions. Any volcanic eruptions में gases निकलेगा, water vapor निकलेगा. The volcanic eruptions are the source of carbon dioxide. The volcanic eruptions are source of sulfide compounds and nitrogen compounds. Sulfide and nitrogen compounds are the key components of the building blocks of life. जहां पर सल्फर होगा, जहां पर नाइट्रोजन है, you'll have amino acids formation, there life will be possible. So, plate tectonics is the key to understanding why Earth as a planet makes life possible. अगर tectonics नहीं होगा, I will not have water. अगर tectonics नहीं है, I will not have carbon dioxide. If I don't have carbon dioxide, I will not have the greenhouse effect. Without carbon dioxide, I will not have photosynthesis. Volcanism, tectonics makes those building blocks of life forms possible. So, अगर कोई planet में I find tectonics as a possibility, वहां पर life possible हो सकता है, वहां पर पानी भी हो सकता है. And the closest we have come to almost being sure, is Mars. Mars has some amount of tectonic process happening. And we have found evidences that there was water on the Mars. Lot of erosion features hai on the Martian surface that tells us there must have been some water. So tectonics is at the root of what makes planets livable, what makes Earth possible as a habitable planet with all its conditions of life, gases and its atmospheric and planet processes. Okay? So let's add one sentence here. The tectonics process is considered as a fundamental mechanism. Is considered as a fundamental mechanism that not only creates the type of crust Earth has, that not only creates the type of crust Earth has, but is also associated with its atmosphere formation, source of water, and the basis of building blocks, in the evolution of life. Okay? So, what is tectonics theory? What are the postulates? What are the type of plate interactions? And what are the type of landforms linked interactions? How do you explain the plate's movement? And finally, the conclusion is fundamental understanding all dynamism of the planet Earth. It's not just the rock formation. इसीलिए अगर किसी planet में हमें fold mountains मिल जाता है, means there must have been water, right? Fold mountains means ocean deposits, marine deposits. So ये सब linked है. Tectonics, convergence, divergence, ocean marine sediments, degassing, oxygen, carbon dioxide, water, सब linked है. So the fundamental to what makes Earth the planet that it is, you link it to the tectonics process. Is it okay, all of you here? Okay. Now a quick discussion on what are the evidences of tectonics. Evidences of a plate tectonics process. Evidences of plate tectonics process. All of these subparts they can be questions itself. I don't see they'll ask you a comprehensive theory on write about tectonics theory. Okay, because आपको लिखना होगा 10 मार्क 15 मार्क में. Okay, so they will ask a part of it. Write a note on the mechanism of tectonics. Write a note on the persevering of fire. एक क्वेश्चन था जीएस में, explain the thousands of islands of Philippines, Indonesia. वो कैसे बने बताओ. Okay, so these type of questions are more possible questions. Yes, Fatima. Yes, we will move towards that eventually. Okay. So what are the evidences? अपने आप में question बन सकता है. The evidences, number 1, all the evidences of continental drift theory are applicable. विचार याद है आपको? The shape fit, we have the structure match, we have the fossil, and we have the paleoclimatic evidences. All the 4 evidences are valid. They tell us continents have moved. But of course, they don't tell us about the mechanism. But ये evidence है. The second evidence are all the evidences of sea floor spreading process. Those 5-6 of them, याद आ रहा है आपको? There is more plus its axial rift valley. There is basalt volcanism at the more, increasing age of the oceans away from the more. We talked about the trench, the accretionary prism, and also the transform faults across the more. The more and its axial rift valley, the basaltic eruptions at the more, the increasing age of the ocean floor away from the more, the presence of trenches, the presence of accretionary prism, okay, along the trenches, and the transform faults across the mores. They all tell us something is moving. Okay? Okay. The third set of evidence are the earthquake evidences. ये एक बार पूछा हुआ क्वेश्चन है. Yes, Abhirup. Okay. So I'm not teaching all this again because I assume अभी पढ़ा है आप लोगों ने, नोट्स बना रखा होगा आपने. ठीक है. So the third evidences, I'll explain this in detail. The earthquake evidences, okay, of the tectonics. Listen though first. Now listen. Earthquakes can happen anywhere. Okay, it's like, you know, fight, a conflict can happen anywhere. But the most likely fight areas can be all the borders of the countries. जहां भी borders, India, Pakistan, India, China, India, Myanmar, borders of Mexico and US, the borders, okay, of Russia and China, the borders of Russia and Ukraine. Okay, so if somebody was to map कि कहां पर war चल रहा है, ज्यादा conflicts हो रहा है, won't I have an idea about where the boundaries are? And the Durand line is a boundary of, because Pakistan fighting Afghanistan there. तो वैसे ही सोचो आप. If this is the earth here, and I have a mechanism of plotting earthquakes, and I find earthquakes तो कहीं भी हो सकता है. But then some zones have more concentration of earthquakes. Some zones have more events of seismic activities. Okay, and these zones will coincide with the boundaries of the plates. In fact, that is how the plates were discovered in the first place. They had one experiment, एक mapping किया था called as worldwide standard seismographic network. They did some mapping of the earth. कहाँ earthquakes हैं? It was on this mapping that they found the lithosphere is not a continuous layer. Some zones have more earthquake, then they study a bit more, then they know because these are convergent boundaries, they are divergent boundaries, they are transform boundaries. That's how they discovered the plates in the first place. Okay, so back to your notes and write down. Under this, point number one, earthquakes are not randomly distributed. Earthquakes are not randomly distributed. They are along mobile zones. They are along mobile zones, active faults. They are along mobile zones, active faults. And are associated with volcanism too. And are associated with volcanism too. Next, write down. Under WWSSN, Worldwide Standard Seismograph Network. Under WWSSN, Worldwide Standard Seismograph Network, there is a pattern to the concentration of earthquake belts. There is a pattern to concentration of earthquake belts. Earthquake belts, which coincide with the plate boundaries. Which coincide with the plate boundaries. Write down. The seismic mapping was the basis of identification of plates. The seismic mapping was the basis of identification of the plates. And the discovery of plate interactions. Okay? So, before tectonics theory, I can't explain why earthquakes yahi hote hain. I said they can be anywhere. But most likely jahan par concentration hai, there are zones of some interactions going on. And that's how the plates got discovered. That's how the plate boundaries were also studied. Okay, this is one of the evidences of tectonics. Number two, earthquake mein hi. An earthquake discussions, the second point. Now see, ये जो mapping किया आपने, this mapping is mapping of earthquakes on the surface. They also mapped the earthquakes through the depth of the earth. Okay, so imagine this is the surface of the earth. Okay, so they have done some mapping here. So they did mapping here, they found lot of earthquakes here, and that's how they know that this is the boundary of the plates. They also have done mapping कि earthquakes underneath कैसे हैं, and even inside the earth interiors. Again, they can be anywhere. Earthquake क्या है कि earthquake is zone of some disturbance. Something is disturbed, something is moving. But again, they found at some locations earthquakes depth may be there is a pattern. Lot of earthquakes are along an inclined plane like this. Okay. So look at what's happening. This is, say, a continent, an ocean, and this is the subducting slab. Because the slab is going inside, this is all mantle. So this slab will rub against the mantle. When rubbing is going on, and remember, in some places the slab also is melting. Slab is melting, the molten lava is rising. Because of this, you'll have lot of earthquakes along this inclined plane. ये एक zone earthquake का बनता है. This inclined zone of earthquake is called as the Benioff-Wadati earthquake zone. And this can only be explained if you understand the process of subduction. So when they found again कि ऐसा एक zone है where earthquakes random है, but some places have an incline, और ये angle approximately is in the range of about 30-40 degrees. This is a, say when you have something going inside, okay, it is going inside like this, ये इसका एक angle अपना एक angle होगा. Okay, this angle is found to be at around 50. This is a physics principle called the angle of repose बोलते हैं. A natural angle where some things will ultimately settle down. So this angle matches that angle, and that's how they found this is a zone where the slab is going inside. ठीक है? Benioff, B-E-N-I-O-F-F, Benioff-Wadati zone. Okay, Benioff-Wadati zone of earthquakes. So back to your notes, write down यहाँ पर. Oops. Yeah, यहाँ लिखो. Give a subheading, Benioff-Wadati zone. Benioff-Wadati earthquake zone. ये second evidence है. Write down. It is an inclined plane in the mantle. It is an inclined plane in the mantle associated with earthquake focus or foci concentration. Associated with earthquake foci. Foci is a plural of the word focus. Earthquake foci, okay, zones. The inclined plane of earthquake foci zones, locations. Write down. This inclined plane at a repose angle, R-E-P-O-S-E. This inclined plane with a repose angle of 30 to 40 degrees. Of 30-40 degrees can be explained only by the subduction process. Can be explained only by the subduction process. The Benioff zone is because of the mantle slab friction. Because of mantle slab friction. As the ocean slab descends into the mantle. As the ocean slab descends into the mantle. Okay. यहाँ पर ocean slab and mantle are rubbing against each other. That's how this zone of earthquake is formed. So presence of this zone again confirms, yes, there is tectonic process going on. Okay. These two are earthquake evidences. अच्छा, ये diagram बना लो अगर नहीं बनाया है. Make this sketch, please. Okay. continent, ocean, ocean. It's also true for OC collisions also. यहाँ पर भी you'll have the same Vadati zone here. Many of Vadati zone of earthquakes. All done? The third one of earthquakes. Yeah, all of you done with diagram, online students? It reaches, yes, generally it is in the zone of upper mantle or part of the upper middle mantle tak. Okay, uske baad the ocean slab completely melts. Okay, this will not go एकदम core तक नहीं जाएगा. पहला 200-300 किलोमीटर, okay, 300 तक maybe, and then it disappears. So by then the slab would have been completely molten. Okay. The third example, the third one is, the third evidence, earthquake में ही है. Okay. Explaining the intermediate and deep focus earthquakes. Explaining intermediate and deep focus earthquakes. ये third evidence है tectonics का. Okay. So सुन लो पहले. Based on anybody, I hope you know what focus means. What's focus of earthquake? क्या है? Focus is what? Is location where the earthquake originates. Okay, जहां से शुरू होता है earthquakes. So there are three types of earthquakes in terms of the depth of focus. They can be shallow focus earthquakes, where the earthquakes are within 70 kilometers, okay, of the lithosphere. Then 70 is a 300, we call that as intermediate. And beyond 300, we call that as deep focus. So earthquake on the basis of focus origin. We can have shallow focus earthquakes, where the focus is within 70 kilometers. We can have intermediate focus earthquakes, where the focus is between 70 to 300 kilometers. And we can have deep focus earthquakes, when the focus is beyond 300 kilometers. There are three types of earthquakes on the basis of the origin, the focus. ठीक है, लिख लो आप. There are three types of earthquakes on the basis of the depth of the focus. The three earthquakes based on the depth of the focus. Shallow focus earthquakes, intermediate focus, and deep focus. Shallow focus, intermediate focus, and deep focus. Shallow focus, I said, within 70 kilometers. Intermediate focus, 70 से 300 kilometer, and deep focus is more than 300. ठीक है. Now, explaining a shallow focus earthquake is not as challenging, because we know we can have landslides, earthquakes. I can have some massive collapse of landform. Okay, some erosion हो गया, कोई mountain cliff गिर गया. I can have earthquakes. The shallow focus earthquakes are, we can explain. Challenge था before tectonics, how to explain the intermediate and deep focus. Because remember, we did not know the mantle motions earlier. We thought Earth is solid. Arthur Holmes, as late as 1928, says the mantle can move. Okay, so to explain these two, we had to understand the mantle is moving, and that is where again tectonics comes in. Mantle motion का मतलब है there is some circulations going on, and there is some type of interactions going on which is not obvious on the surface. So this became the basis of knowing the mantle dynamism. Remember, convection cells can be at any depth. So these are linked to convection cells. These are linked to, remember, mantle plume yaad aa raha hai aapko? Okay, lava can come from deep mantle core boundaries. Okay, so mantle plume tells us that mantle can be molten. The Benioff zone operates in intermediate depth zones. Okay, and plus think of the seafloor spreading. So all of that can explain these type of earthquakes. जब तक हमें tectonics नहीं पता था, this was not easy to explain. Write down. Write one small paragraph right down. While it is relatively easier to explain shallow focus earthquakes, the deep and the intermediate focus earthquakes, cannot be explained without the knowledge of mantle dynamism and plate interactions. Without the knowledge of mantle dynamism and plate interactions. Next paragraph. Convection cells, mantle plumes. Convection cells, mantle plumes. Subduction process are all associated with the deeper earthquakes. Next. Sea floor spreading and localized volcanic eruptions because of hotspots. Sea floor spreading and localized volcanic eruptions because of hotspots can explain all the three types of earthquakes. ठीक है? What's this? अगर ये surface है and we have a rising limb like this, or maybe I have a localized mantle plume. We call these as hotspots. Hotspots are linked to the mantle plumes. इसमें क्या होगा? Earthquakes यहाँ भी होगा, यहाँ भी होगा, यहाँ भी होगा, यहाँ भी होगा, and when breaking the crust, यहाँ पे भी earthquakes होंगे. So the deep earthquakes, the intermediate earthquakes, and shallow focus earthquakes. I can explain जहां पर भी you have sea floor spreading. Same deep earthquakes, intermediate earthquakes, and shallow focus earthquakes. Again, I can explain with the mantle plumes. Take all of you here. Next paragraph. Subduction boundaries can explain shallow earthquakes and intermediate focus earthquakes. कैसे? The continent and we have subduction. Subduction हो रहा है, तो remember, there will be collisions here. There will be scraping of accretionary prism here. When it's bending, this slab can crack here. You all imagine here, slab ऐसा का bend होगा, the upper part getting stretched. Okay, this can open up, crack. You could call this as shear cracks. ऐसे cracks बन जाएंगे where there are bends. So this cracking can cause again earthquakes. And you already know about the Benioff zone here. The subduction zones can explain the shallow focus earthquakes and deep and intermediate focus earthquakes. Shallow focus because of collisions, because of a scraping of the prism, because of shear fractures at the trenches. Take a look within bracket. Shallow focus because of collisions, comma, scraping of the accretionary prism, and because of shear fracture at the trenches. Because of shear fracture at the trenches. Is it okay, all of you? So, this explains. So, trench locations are zones of earthquakes. हमने पढ़ा भी already. जहाँ trenches होगा, you can have tsunamis. Think of Kamchatka, think of earthquakes, tsunamis, Indonesia में जहाँ पर Sunda Java trench है. So, trench locations are areas of powerful earthquakes, which can create tsunamis also. Okay, and उसी में ही the intermediate focus earthquakes explained by Benioff zones. The intermediate focus earthquakes linked to the Benioff earthquake zone. Ajit, scraping of accretionary prism or scraping of the ocean floor. That rubbing action can create earthquakes. Okay. Next paragraph, same discussion. At CC collision boundaries, and transform boundaries, as CC collision boundaries and transform boundaries, we can have very powerful shallow focus earthquakes. We can have very powerful shallow focus earthquakes. Okay, so there's no lava coming out, but these two, remember, strong compressive forces. There's crushing going on. Okay, there is mountain upliftment going on. So this can create shallow focus earthquakes. And you already know and understand, okay, the two rubbing action, like San Andreas fault, can also create earthquakes. So the pattern of earthquakes hai, okay, where shallow, very deep, this was not very well understood till we knew tectonics theory. अगर पूछेगा question on how are earthquake evidences of tectonics, ये आपका answer है. Is it okay? Earthquake evidences in terms of WWSSN, earthquake evidences in terms of Benioff-Vadati zone, and earthquake evidences in terms of the three types of earthquake foci depths. Shallow focus कहाँ possible है? Where can I have intermediate focus more likely? And where can I have deep focus more likely? Take all of you? Okay. That explains earthquake evidences of tectonics. Okay. ABC हो गया आपका? Now come towards D. The next evidences. Vatsala, there can always be events without tectonics also. Say, think of you have landslide हो गया. Think of construction activity going on, or think of tunneling activity going on. Think of, because of some local reasons, some landform collapse कर गया. तो shallow focus earthquakes are not the trickiest concept. वो बता सकते हो कि ठीक है मूव हो रहा है तो हो रहा है और क्या. Shallow focus earthquake even Wegener can explain, okay, because Sial is moving. But Wegener does not know about mantle, right? So Wegener theory can't explain why earthquakes are at specific locations inside the mantle. That's why shallow focus are not the trickiest one. The bigger challenge is explaining the specific locations where we have intermediate and deep focus earthquakes. Okay, we move on. The next one is, ये भी अलग से पूछा हुआ question है, okay, and this has been asked in a prelims GS से पूछा है. Hotspot evidence. Hotspot evidence for tectonics. Hotspot evidences for tectonics. देखो hotspot मैंने पढ़ाया नहीं है. I will give you some heads up on this and then we'll build up again when I'm discussing volcanism. Okay, सुन लो पहले. So imagine this is some plates interaction going on. Either collision boundary हो या फिर divergent, whatever. I know this zone, if it is subduction zone, if it is a Moore zone, these areas can have volcanism. Okay? Because subduction mein ocean floor is melting. Iron arc formation or the volcanic peaks of Andes types, समझ में आता है कि plate boundaries can have volcanoes. These are the boundary volcanoes. Sometimes I can also have volcanoes away from boundary inside the plate. We call these earthquakes or volcanoes as intraplate. Intra का मतलब क्या होता है? Inside. ये प्लेट बाउंड्री पे नहीं है, ये इंट्राप्लेट है. Okay. The plate boundaries are linked to convection cells, either diverging or converging. ये जो है localized है. The localized ones are linked to, okay, mantle plumes. ये convection cells बने नहीं है. Localized area, lava is rising, magma is rising and coming out and erupting here. And as a rule, they always come from core, mantle, boundary. Deep mantle से आता है. And this type of lava is going to be very, very fluid lava. This is, okay, very basaltic lava. The lava which is formed because of melting mantle will always create basalt. Okay. Because it is not across large areas, small pockets हैं, we call these as hotspots. ये hotspot, this is a linear belt of volcanoes. The localized ones are called as hotspots. And abhi bhi, we are not very sure about why these generate. ये क्यों होते हैं अभी भी नहीं पता हमें. Yes, interiors are hot. That's a very naive explanation, right? It's like, why am I bleeding? Because I have a cut. भाई क्यों cut हुआ? कहाँ गिर गए? कैसे चोट लगा? That's a bigger example, right? A big discussion. So yes, I understand. Inside it's hot, but why here and not here? Okay, why this area is melting and not some other area is melting? That's some reason we do not know. Okay, but we know that they are, because they're very, very fluid, very basaltic. I know they're coming from deep. Okay, as I go inside the Earth's surface, remember we have ultramafic term use किया था मैंने. Okay, as I go, it becomes more and more mafic, more and more mafic, more and more basalt. And यहाँ पे इतना basaltic है, basalt lava will be a very fluid lava. वो आराम से बाहर निकलेगा and form some features here. Example of hotspots, Hawaiian Islands हैं. Hawaiian Island is not a part of a boundary. Hawaiian Islands. If you know about an area near Mauritius called as Reunion Islands, ये भी localized eruption spot है. वैसे ही localized spot है called as Galapagos Islands in the Pacific Ocean. ये कुछ examples of hotspots. Deccan lava flow itself, Maharashtra का region जो है, it also is because of some hotspot. Okay, so write 2 lines लिखो आप. Write 2 lines. Apart from volcanism along the plate boundaries, within bracket, subduction boundaries or divergent boundaries. Subduction boundaries or divergent boundaries. Bracket closed. There can be intra-plate volcanisms away from the boundaries. There can be intra-plate volcanoes away from the boundaries. These are localized. Not a part of convection cells. They are localized, not part of convection cells, and have extremely fluid basaltic magma. Such volcanoes are called as hotspot volcanoes. These volcanoes are associated with, they call as hotspot volcanoes, they are associated with mantle plumes. The convection cell nahi. I think you all imagine now, right? Convection cell kaisa hota hai? A circulating system. This is a localized rising lava. So these are mantle plumes. Okay, with magma sourced from deep core mantle boundaries. Okay, I think you understand what hotspots are now, all of you. Hotspot is one special type of volcanic eruption. It is not linked to the boundaries, not linked to more, not linked to trenches, not linked to subduction processes. ये away from boundary होते हैं, inside the plates. Okay. Now, what we know is that these hotspots, they themselves don't move. Okay. Because see, this is the core of the earth. This surface of earth hai. We have rocks. Rocks, I have told you, are mixtures. Rocks are not compounds. So even if I say that this is a mantled rock, some form of pedotite, the fact is, the rock here is not same as rock here. Is not same as rock here. Is not same as rocks here. So when lava comes out and I find this lava A, okay, और हमेशा यहां पर A ही है, which means ये लोकेशन फिक्स्ड है. अगर यहां पर लावा निकल रहा है और this lava is lava B and B is not same as A, what I know is कि ये A move नहीं कर रहा है. Hope you got the point here? So we have reasons to believe the hotspots themselves don't move. They are fixed. The type of lava link is also fixed. They will not change. But what we have found is very interesting. We have found कि अगर ये plate है, okay, and we have some hotspot here. This is the active hotspot, present day times, say last 1000 years old. Okay, we find there are islands like a linear chain like this, where the lava here is A type, lava here also A type, yahan par bhi A type, ye bhi A type, ye bhi A type, and there is an increasing age. This is probably 5 million years old, this is probably 2 million years old, this is 1 million year old, this is 10,000 years, and this is 1,000 years. I have found this. On the Earth's surface, we have found chains of islands of the same volcanic rocks, but of increasing age. How do you explain this? Okay. And I know ye active, ye sab active nahi, all of them are dormant, all of them are extinct. One mechanism of explaining is that this is the hotspot. Maybe the hotspot was here once upon a time, then it came here, then it came here, then it came here. That's how it has been forming. But I've told you, hotspots don't move themselves. Ye chain kaise bana hoga? Only when the plates is moving. So hotspot is like a tracing pen, and the plate has moved like this. So this location was here once upon a time, active volcano. Aage chala gaya. Okay. Now active volcano here. Aage chala gaya. Active volcano here. Aur aage gaya. Active volcano here. So hotspots become evidences of the plate motions. If I study the age of the islands, I can tell at what speed the plate was moving. I know the distance between them is 1000 kilometers, and this is 1 million years old, this is 50,000 years old. Mujhe pata hai na, distance by time is your velocity. By knowing the direction, I can tell the path of how the plate has moved. Okay, so tracing such hotspots can tell us about how the plates are moving. Is it okay? Write 2 lines on this. Shweta, please don't go that route, please. आप कंट्रोल करो ये, आप मैग्नेटिज्म में कहां पहुंच गए? Okay, मैं भूल गया हूं, मैं पढ़ के बताऊंगा आपको. Okay, अभी इतना ही याद किया था कल रात को, इतना बोल देता हूं. Okay, write down. Observation क्या है? Observation is hotspots are known to have traced. Hotspots are known to have traced long linear chains of volcanic islands. Long linear chains of volcanic islands with increasing age away from the active hotspot location. From the active hotspot location. I repeat, hotspots are known to have traced chains of islands with increasing age away from the active hotspot. So, ये जो मैंने बताया, दिखा दिया मैंने. Hotspot is tracing a linear chain of islands with increasing age away from the active hotspot. Within bracket, write down. These linear chains are not like the archipelagos. They are not like archipelagos along the OO collision boundaries. They are not archipelagos along the OO collision boundaries. देखो, ये फर्क क्या है? Hotspot, volcanic chain, how is it different from the archipelagos? Both of them are linear chains. Archipelago will be at OC convergence. Archipelagos में all the islands can be active. ओके, जापान भी एक्टिव है, फिलीपींस भी एक्टिव है, क्यूरील भी एक्टिव है, इंडोनेशिया भी एक्टिव है. I hope you remember, right? This year, Kuril also have volcanism, Japan also has volcanism, Philippines also has volcanism, Indonesia also has volcanism. ये पूरा चेन एक साथ एक्टिव है. Okay, so in O collisions, all islands can be active at the same time. They're always linked to trenches. पक्का यहां पर एक ट्रेंच होगा. Okay, they're always andesite eruptions and they're always very violent. They always are linked to back arc and fore arc zones. Okay, so archipelago type of chains ये फीचर है. They're linked to O collisions. All the islands can be active at the same time. Okay, they are linked to trenches. Trench के साइड में होंगे ये. They always are andesite and very violent. Tsunamis बनेंगे. And they are having back arc and fore arc. Towards the trench is fore arc. ये back arc basin है. Hotspot chains, they are not O collisions. They're because of mantle plumes. Okay, not all, only the youngest island will be active. These are basalts and they are not violent. और इसमें कोई बैक आर्क एंड फोर आर्क नहीं होने वाला. They're not linked to O collisions. They're linked to mantle plumes away from boundaries. सारे island active नहीं होंगे. Youngest one, if activity is there, the youngest one will be having volcanoes, not the others. Others are old, extinct volcanoes. Basalt eruptions and there is no fore arc and there is no back arc zone. I am anticipating आपको ना ऐसे क्वेश्चन पूछे जाएंगे. 10 marks में लिखो compare okay hotspot volcanism with okay archipelago islands. 4-5 points on this. Is it okay all of you here? Okay, so hotspots ये हैं. So I'm saying the hotspots are known to trace linear change of islands with the age of islands increasing away from the active islands, and they are not archipelago types. Right, next. Because it is known that hotspots themselves don't move. Because it is known that the hotspots themselves don't move. The only explanation the hotspots themselves don't move. The only explanation why such island chains are formed. Why such island chains are formed? If we explain with lithospheric motions. If we explain with lithospheric motions. It's like, I have a paper, I have a pen. Okay, I'm drawing a line here. दो ही तरीका है. Either the pen is moving and drawing a line, or keep the pen stationary, let the paper move. ये दो तरीका है आपका. Because we know that the hotspots don't move. The only way you can explain the change of islands is if the lithospheric plates are known to move. Write down. Yes. Because the rocks are same. Because the rock types are same. You forgot this conversation I was giving you here. This is not all same type of rocks. The rocks here will be different than here, everywhere. So if this is moving, then the rock here, A, When this moves and comes here, you'll have a rock B. It is not the same type of rocks. The rocks here, okay, can't be same as rocks here. So in that case, the two type of lava will be different here. No, that's ruled out. Convection cells means it will be a divergent boundary type. Let's trust कुछ पढ़ा होगा उन लोगों ने. Okay, don't go the geophysics way beyond a point. I say please stop. How they know? We'll trust them. Okay, the Princeton University guys are doing this. Okay, so okay, they are better than okay, Noida में colleges. Okay, so the logic is that the lavas, if the hotspots are moving, the lavas can't be same. That's the main argument given. Okay, and see, when you talk about evidences, no, it is not only one evidence proving the whole thing. You're linking series of evidences. Okay, when you put them together, it's like you know, say I know this man murdered a person A. तो एविडेंस सीरीज होगा. फिंगरप्रिंट्स भी मैच कर रहा है, एलिबाई भी रॉन्ग है, किसी ने देखा भी है शायद, मोटिव सब जोड़ोगे, then you say, oh, this man is the culprit. So it's not only about one evidence. Okay, you have WWSSN, you have got the foci, the Benioff zone, you already have Wegener's ideas, you have seafloor spreading. सब मिलाकर ये भी एक evidence बन रहा है. So when you put them together, now it looks like a complete story. Okay, write down one more sentence. लिखो आप. Tracking the direction of the orientation of the island chains. Tracking the direction of the orientation of the island chains, comma, the age of the rocks and the distance between them. Tracking the direction of orientation of the chains, comma, the age of the rocks and the distance between them. The direction and rate of the plates can be objectively calculated. The direction and the rate of the plate motions, the plate movement. The direction and the rate of the plate movements can be objectively calculated. Okay. So in the Pacific Ocean, as बहुत से studies हैं, I'm giving you one of them. This is the most popular one. Your book will have it. Okay. So think of this. Okay. This is Aleutian Islands. So we know islands are here, सब पता है हमें. And you know boundaries. Apart from this, we have some islands here. We have some islands here. And we have islands here. Okay. These islands, this is the Hawaiian group of islands. This is called as the Midway Islands. And these are called as Emperor Sea Mount Chain Islands. ये तीन group of islands हैं. And if you trace it, these islands are like a linear chain like this. This is the oldest one. Okay. These are a bit more younger. This is the most recent one. Hawaiian Islands mein southernmost island here. Okay. This has active volcanoes. And all of the others are dead. ठीक है, ये ड्राइंग कर लो पहले. Draw this sketch, all of you. This north-south chain called as Emperor Sea Mount Chain. Emperor Sea Mount Chain. Then we have the Midway Islands, and then we have Hawaiian Islands. These are oldest. Midway Islands about 1 to 2 million years old, and these are the youngest ones. Okay, and write one sentence. The study of North Pacific Islands. The study of North Pacific Islands of Emperor Seamount chain, Midway Islands, and Hawaiian Islands. Have helped track the north and northwestward movement of the Pacific plate. North and northwestward movement of the Pacific plate. I made a mistake here. It's around 10, not 1 to 2. It's about 10 to 20 million years old. ये जो islands हैं, 10 to 20 million years old. And this is the recent one. These go back to almost 30-40 million years old. Okay, so I just have one diagram with me. Don't draw it, just know this. Okay. Oh, some problem here. No, I can't show it today. Something. चलो, I'll show you afterwards. Maybe next class में बता देंगे आपको. So, oh, now I am some other. Yeah. So आपके book में भी है. If you want, in your Savinder Singh book, it is page 206. There's one diagram of this. Yes, Surya, but I'm not able to show the screen. So page 206 has this Pacific Ocean ka Emperor Seamount chain. Yeah, that's a different point. That they are not volcanic, violent is a different point. What I want to tell you here is how the orientation helps me know the direction of the plate movements. Okay? So page 206 is one reference you could have. I'll mention the page numbers. Page 185. Maybe आगे पीछे देख लेना. It is where the chapter 11 starts. Page 185, 186 and 187. Hardly about 3-4 columns हैं. Page 185, 186, 187. Okay, that's your tectonics theory. Okay. Page 193 has the cause of plate motion. Page 193 has the cause of plate motion. 194, there's one paragraph comparison on tectonics and drift theory. Comparing tectonics theory and the drift theory. And there was and in chapter number 6, page 117 and page 118, 119 and 120 is the drift theory. Page 116, 117, sorry, up to 120 is the drift theory. Then some bit of sea floor spreading is page 124, 125 and 126. Okay. Kul mila ke maybe about 10 odd pages in total. Read this across maybe today and tomorrow, but don't read line by line. We want quick scanning. Pick up some diagrams if you can, because bulk of what I have discussed takes care of your content. Maybe some words, some diagrams. It helps you consolidate your notes better. Okay, all of you? Chalo, fine. We continue tomorrow. Bye-bye. Today, those who are part of enrichment batch, we have the class at 4 o'clock today. There was some change of date I have done. Okay, so we have a class today. Yeah, enrichment students, if you are enrolled with us at 4 o'clock. Yeah, same live and also, online, offline.